Yeah, but have you done interviews in general, or just your first interview as well?
Um, I've done like FizzBuzz or like LeetCode
Okay.
Easy interviews for internships. That's it.
Okay. Okay. So you've done these problems before.
Yeah, I have been doing LeetCode for like 2 months, yeah,
Okay, I got
and
it.
before as well. Yeah, yeah. Thank you.
Okay, I understand. I understand. All right. Yeah. Okay. Cool. Looks like you're in. What's your preferred language?
Python, please.
Python's good. Okay, sounds good then. Yeah, then we'll get into it pretty soon then. So let me just have a quick look on my side before I. Let me just make sure I got this. Okay, we're gonna do. Let me take a look. Where the hell did my link go? Um. Okay, sounds good. Then let's get into it. So, I mean, first of all, welcome. Thanks for participating. That's always what I start with. This is an hour long, right? In a real interview, it'll be an hour as well. But in the hour, you'll usually have about 45 minutes to maybe 50 minutes for the actual problem solving. We'll just dive right into that, right? So we'll just get right into that today. We
Okay.
got one problem. If we were fast, maybe we'll do two,
Okay.
and then afterwards we'll do questions, feedback, etc. How's that sound?
Sounds perfect. Thank you.
Okay, great. So let's just start with a problem here. This problem is gonna be called group anagrams. Have you heard of it?
I've heard of anagrams before.
Okay, so let's do this problem. So it's called group anagrams. All right. So
Okay.
I'll dictate the problem, and you can go ahead and write down the notes. You can ask me any questions you need. So
Okay.
this problem called group anagrams. The input to this function. So I want to write me a function called group anagrams. The input
Okay.
is going to be a list of strings,
Okay.
and the output is going to be a list of strings. Okay. And the goal of this function is very simple. It is to group all the words together into one list, such
Okay.
that all the words in a list are anagrams of each other.
Okay.
Do you know what an anagram is?
Yeah, it's just that you could order the letters in any way, right? And then I guess that would be like the same word, I believe.
Yeah.
Okay. 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 So I guess I have heard of this umpire framework, so maybe I'll try that, and then we can maybe get some feedback on how that works for technical interviews.
Okay.
So just to make sure I understand the input is, I guess, a list of strings, and then the output is a list of the strings. Um, and then, yeah, I guess these are just different words, and then we have to order them into a list of strings. Right, okay, that makes sense. By their anagrams, so common anagrams. So I guess maybe I could start with some assumption slash clarifying questions. So first off, I guess, can I assume that the input list is always existent, like it's not empty?
It could be empty.
Okay, um, input list empty. And then can I assume that the strings only have characters, like they don't have numbers or spaces, like it's just single words?
Yeah, you can assume that.
Okay, single words, only characters. Can I assume that it's only lowercase characters, or could it be lowercase and uppercase?
They can be any ASCII, alphanumeric characters, or not numeric, just alpha characters. So okay, upper and lowercase. Yeah.
Okay. So if I have, like, for example, the word hello and like, for example, would this be considered, or sorry, let me just make that lowercase. Would this be considered an anagram? Like, should we do case matching or not?
So that case should not be considered an anagram.
Okay, so I'll say case sensitive. Okay. Um, okay, so I think that's maybe all my clarifying questions for now. I could maybe clarify later. And I guess example, maybe test cases just to confirm I understand. So if we have, like, for example, hello, um, Ali, Ali, and maybe like that, for example. So I guess the output for this one should just be a list of hello. So just to confirm, would this be the output to that input?
Yep, that would be invalid output. Yep.
Okay. So I guess I could maybe move on to the next step, which is where I think of some approaches. Um, so I guess maybe my initial approach would be to maybe sort each word. Um, yeah, I think I would sort each word and maybe use a hash map to check for existence. I would sort each word, have that be the key, and then have the values be, if when sorted, it matches that key. So I guess if I were to write that down, I would just say sort each word, use hash map to check for existence, and values is list of the words. Though I'm assuming that's the intuitive solution or the naive solution, because I guess for each word we would have to go through them. And if we say each word is of length n, then that means we would have to sort each word, and then let's say each word is of length k. We would have to sort each word and do that n times. So I don't think that would be too efficient. And then I guess the space complexity, I guess would be the entire list as well. So there's probably a better way.
Mm-hmm.
Okay. So I guess maybe alternatively what we can do is, you said it would only be ASCII characters, right?
Yeah,
Like uppercase and lowercase. So
that's
maybe
right.
what we can do is we can still use a hash map, but instead of sorting it, and since there's no spaces, so since it's individual words, we could just maybe get the frequency of each letter. And then, yeah, I guess we can just check the frequency of each letter, and then if there's a key that exists with that frequency. So I guess the frequency could maybe be a frequency of, I guess, 26 times 2, just because there's lowercase and uppercase characters. So we could just have the frequency, and then that's the key. And then the value is going to be the words themselves from the list, right? So I guess if we were to think of the time and space complexity of this one, we're iterating through each word. And then when we're iterating through each word, we only have to do a single pass to find the frequency, check if that frequency array exists. If so, then append to that list. Otherwise, create a new list and append to that list. And I guess the key itself would be of static size because the number of, I guess, letters in the alphabet doesn't grow with the input. And then I guess the space complexity would also just be O, and I believe just because of the hash map. So do you think maybe approach 2 is a good solution to proceed with?
Yep, I like approach 2.
Okay. So I guess I'll say just for plan, implement approach 2, the hash map, and then to implement. So I guess what we can do here is we can have a default dict first. So I'll just say, or I guess I'll create the function first. So I'll say def group anagrams, which takes as an input a list of strings, which you can just call words. And then I can create the dictionary. So for the dictionary, I'll just call it frequency for now, and I'll make it a default dict of type list. So we don't have to create that list. And then I guess I have to import it. So I think it's import, or I think it's, sorry, do you know what the API or the collection library is for default dict? Is it just collections?
Yep, it is.
Okay, so from collections, import default dict. Okay, thank you. And then once I do that, I guess I could have I could just iterate through each word. So I'll just say for word in words. Then I have to iterate for each character in word to first create that key or find a key. So for character in word, and then for each character, I would want to find or determine that key. So I guess before I do that, I'll create a list. So I'll just say here char frequency, which equals, let's just say initially they're all equal to 0 times 26 times 2, which is 52. And then I guess I could just map the ASCII values. So I believe what I can do is for each character, I can get the ASCII value like this. I'll say order C minus order A, and then just say that's the, I guess like the where it belongs in the char frequency array if it's lowercase.
Okay.
And then I guess if it's uppercase, I would have to handle that separately. So maybe what I can do is I can check if it's lowercase or uppercase. So maybe I can say if C equals C dot. Is there a way to check, like, is there a lower function on a character? Like, can I do C dot lower? Does that exist?
You can assume it does.
Okay. So if it's lowercase, then index equals this. Else, we can say index equals the order of the character minus the order of a capital A, and then we'd have to multiply it or add some scaling factor. So I'll say index equals 0. And then if we do this, I think we can just say 26 plus this should work, right? Because this would map to indexes 0 to 25, and this would map from indexes 25 to 51, I believe, and both are of size 26. So once I do that, then I'll just say here frequency of char frequency dot append the given word. Though I guess sorry, I might not be too clear on this, but can we have a hash map with a key of a list, or would that not be possible since it's mutable?
That would not be possible.
Okay, so this approach is an issue. I guess maybe one thing I can do is once I generate all of this, I could convert char frequency to a tuple because that is immutable. So I think I can just say tuple and pass in a list. Would this be possible, converting it to a tuple and using that as a key?
You can assume that works.
Okay. And then once I do that, I believe I populated my hash map. And then I just have to return the output. So I can just say here, I guess I can just convert it to a list of lists. I'll just say here output equals a list. And then I'll just say for key val in freak.items. I'll just say here output append val, which is a list itself, and then return output. So I guess once I do that, maybe the next step would be to go through the tests just to make sure it works. So let's see here. I guess maybe we can just pass this and walk through the test. Any concerns or comments as of now, or is it good so far?
You're not using the index variable.
Yeah, I just realized. Okay, yeah, that's an issue. I have to update char frequency, of course. So I guess once I do that, I'll say char frequency at index plus equals 1. So I guess, yeah, that's actually me using the index. So it'll discount the frequency and increment it by one. It's initially set to 0, so if there's more than one, it'll just add one. And then it'll find this for each one and append that word. Okay. So should I walk through an example test case now?
Yeah, you can pick one to go through. Yeah.
Okay. So first we'll take the word hello. We'll iterate through each character and then it'll create that sharp frequency. So I guess maybe you can focus on this bit here. So it'll be a bunch of zeros, and then once it finds h's, this, so we can just say 0 dot dot dot, and then once it finds h, it'll have a 1. It'll have, I guess, like a 1 for an e, for example, and then dot dot dot, and then it'll maybe have 2 for the l, and then I guess dot dot dot. So where the dots just represent the zeros, then it would have 1. That, and then it would just have dot 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 for all the uppercases and remaining letters. Then we move to LE. It should have its own frequency map. So if we can abstract and trust that this works, it would have its own frequency map. And then for lowercase LE, this would have a 1 at index 0, while this would have a 1 ideally at index 0 plus 26, which is index 26. So these don't match, so they'll be in separate parts of the frequency dictionary. And then for this one, hopefully this should have the same frequency as the first hello. So it should have this, since it has the same frequency or the same key, it would just be appended to the same value array. And then I guess after that, we can just iterate through the dictionary or the hash map, and we can check for all the keys that are the same, just append the value, which should be hello and hello backwards, and then Ali in the second list, and then Ali with the lowercase in the third list. So I think that would work with this test case. Is this good for the initial walkthrough, or should I go into more detail?
No, I think I'm okay with that. Yeah.
Okay. And then I guess just as a final step, we can just evaluate the implementation. So I think just to confirm, the time complexity was as we suggested, which was iterating through all the words. And then I guess we have to iterate through each character, so we can assume that the longest word is of k characters. And then the space complexity is also, I guess, just O of n, where n is the number of words. And
Okay.
yeah, I think that might be as efficient as it gets.
Okay. I'm happy with that. We can move on for now.
Okay.
Okay, great. So let's move to the second question. The second question is not related to the first.
Okay.
So this question is called find delay, find maximum delay. In this question, I would like you to write me a function called find delay, which returns the longest possible delay to travel between a given source node and the given target node. Okay? And so the
Okay.
input to this function will be a source node, a target node, as well as a representation of a graph which you can choose. So you can be, for example, an adjacency list, or
Okay.
a pair or list of edges, for example. So you can choose the type of graph representation, but you'll also be given an input node and a end node.
Okay. Okay. So I guess yeah, we could just clarify the problem first before starting. So just to make sure I understand the problem, the input could be graph representation of any type. So let's maybe say for now it's an adjacency list, which would I guess be like a hash map where the key is the source node and the destination nodes are in a list. And then the output would just have to be of type int, and that would just be the longest delay between source and destination node. Okay. Is that correct?
Yep.
Okay. And then let's maybe just for the assumptions or clarifying questions. So I guess my first question, as usual, would be can we assume that the first off the graph does exist, like it has the source and destination node, or could it potentially be empty or only have a source node or only have the destination node?
It must have at least both nodes.
Okay, so graph empty has both source and destination node. And then I guess so we have to find the longest delay, not the shortest delay or shortest path. So would the longest delay just be defined as the shortest path between source and destination node?
The longest delay is the longest path.
Okay. So longest delay is longest path. Okay. Let's see. And then can we assume that the source and destination nodes are just they're just numbers?
What do you mean by the number?
Sorry, so like would the graph just be a bunch of nodes where each of the nodes are just a simple integer number, or would it be like, for example, strings or anything else? What's the data type of each of the nodes?
You can pick.
Okay, maybe we can just assume ints for now, for easy comparison. Okay, and I guess so for an example input, let's say we have a hash map, where we have a key of, I guess, 0, which maps to 1, 2, 3. Then we can maybe have 1, for example, which goes to 2 and 3. And then we can maybe just say 2, which goes to 3. And we can say the source node is of type int, which is 0. The destination node is of type int as well, which we could say is maybe 3. So I guess in this case, maybe the output would just be from 0 to 1 to 2. I'm sorry. So 0 to 1 to 2 to 3. So the output would be, I guess, the longest delay. So when you say delay, would it include the arrows, right? Not necessarily the nodes. So in this case, the output would be 3, not 4.
Yeah, it would be 3. Yeah.
Okay, okay. So I guess even though they could have gone from 0 straight to 3, we want to find the longest path. Okay. I guess maybe we can try to match this to an approach or a data structure. So obviously we have a graph, so we would use DFS or BFS. So I guess since we have the flexibility to choose either or, maybe what we can do is we can do an iterative BFS where we start at the source node and try to, I guess, yeah, just go to every node from there and every node from each of those nodes or from each of the neighbors. And the iterative BFS would have a queue or a data structure, which would keep track of the, I guess, like the current node and the number of delays thus far. And then I guess we would check if we found the destination node while popping from the queue. We can just update the max delay if it's greater than the existing delay, and return the max delay. So I guess with this solution, the idea is that the time complexity would be to iterate through all the vertices and edges, and the space complexity would be to the queue would store all the vertices, I believe, in this adjacency list. So it would only store these numbers in both queue and, of course, the scene hash set. So we'd, I guess, also have like a scene set to make sure that we don't go to the same node twice.
Okay.
Do you think this solution is viable or should be implemented?
We can go with this. Yeah.
Okay. So I'll just go ahead and implement this. So I guess we can, yeah, just implement maybe a traditional BFS and then go from there and customize that as necessary. So we'll have a queue which equals a deck, and I guess I'll have to import it. So from collections, import that deck. So from deck, we'll start with an iterable, and the iterable would be the source node. And then I guess it would also store the number of delays thus far. So I'll just say source node and 0. And I guess, oh, sorry, this should all be in a function. So I'll just say def find delay. So it takes a source, a destination, a graph. Okay, so we have that initial queue, which starts with the source node, and then we'll add that to the scene hash set as well, so we don't revisit that node later. So again, that would, I guess, I think it's seen we would just track the node. So we can just have that initial source node. And then I'll say here while queue, so while there exist nodes in the queue, we can pop the current node and the number of delays from the queue. So dot pop left, which would pop from which would pop in a FIFO fashion, I believe. And then we would just say if node equals a destination, because it's just integers. If so, then we would update the max delay. So I'll say max delay equals float. So since the max delay, I could maybe start with a negative infinity. And then since I start with negative infinity, I can just say here max delay equals the max between max delay and I guess the delays. And then I guess we would just return max delay at the end of it all. So the next step would just be to iterate through all the neighbors of the current node. So I'll just say for neighbor in graph node. So once we iterate through every neighbor, we want to check if it's in scene. So I'll say if okay, I guess this might be an issue with if we've seen the node already, like if 3 was here first, it would just go to 3 and not visit 3 when it's in 1. So I guess maybe with scene, you would have to track both the node itself, and you would also have to track the number of delays, which I guess would start with 0, just because if this was, for example, 3 and this was 1, it would just go straight to 3, update max delay, and then it would never be able to go to 3 again. So I think, yeah, in the scene, we would have to keep track of the node and the number of delays. So then I'll say here, if neighbor and delays +1 and not in scene. So if it's not in scene, then we could add it to scene. So I'll say add the neighbor. Oh, sorry, I should add it as a tuple. Add the neighbor and delays +1. I'm not sure why that's complaining. Do you know why there's the issue with this? Or is that just because I guess we haven't specified graph? Because it's of type unknown?
Set of tuple. You can ignore it. It's fine.
Okay. Okay. So of course I'll also have to add it to the queue. So I believe that's just append to add it to the end. And I'll add a neighbor and delays +1. So I think once we do all of this, this function should be complete because they'll iterate through every node and every delay, and then just return the one with the max delay. So I guess make sense to go through an example test case, or are there any questions, concern, comments with the code?
We can go through an example.
Okay. I guess I'll just review this. So I could maybe copy this example input and hope I get the example output. So I guess I'll start at 0. I'll just have a scene data structure and a queue data structure. So with a scene, we initially have a 0, 0, and then likewise with the queue. And then we have the max delay, which is just set to negative infinity thus far. Okay, so the queue is not empty, so we pop from the queue, and then we'll say node is 0 and delays equals 0. So the queue is empty. So if the queue is empty, we check does the current node we're at equal the destination node? No, it doesn't. So we leave max delay as is, and then we iterate through all its neighbors. So I guess in this case we would add. We would first check if 3 and 1 isn't seen. It's not. So we would add it to scene. So I'll just say 3 and 1, add it to scene, and then add it, of course, to the queue as well. So once we add it to the queue, we'll do that for all the other nodes. I guess we can just duplicate this, change this to 2, change this to 1, and then add all these nodes to the queue as well. And once we do that, we've iterated through all the neighbors of that initial node. So we would go back to the top of the while loop, and we would pop again. So when we pop here, the first node was 3, so I guess the node becomes 3, and the delays becomes 1. And we check, does the node equal the destination node? Yes, it does. What's the max between 1 and a negative infinity? It's 1. So we change this to 1. And then we iterate through all the neighbors of the next node. So I guess maybe just to make it a bit shorter for the example test case or for the walkthrough, we can just have a graph like this. So then here we would just pop that 3, 1, of course. And then once we pop that, we would go through all the nodes in we'd go through all the neighbors of 3, which don't exist. So this loop would, so I guess this would just never run or never go into it. And then we go to the next iteration of queues, which is 2, 1, and then 2, 1 again doesn't have any neighbors. So we would just delete that as well. Then we look at 1, 1. So we pop it, the number of the node would be 1, the delay would be 1. So once we pop that, we check, does the node equal the destination? No, it doesn't. Let's go through. So in that case, we would go through this inner loop, which is to go through all the neighbors of node 1, which is 3. We check, is 3 and 2 in scene? No, it's not. So we can add that to scene. So we can add that to scene, 3 and 2. And then we'll add it to the queue as well, 3 and 2. Then we iterated through all neighbors. So we'll end this iteration with node being 1, delays being 1. Go back to the top of the while loop, and what's in the queue? A node of 3 and delays of 2. We check, does a node equal the destination node? Yes, it does. So the max delay would be the max between the existent value, which is 1, and 2. 2 is a higher value. So I believe we would update the max delay to 2. And then we would iterate through all the neighbors of 3, which don't exist. The queue is empty. So then at the end of all of it, we would return max delay, which is 2.
Okay.
Did that walkthrough look right, or did I miss something?
No. That's good for now. Let's
Okay.
move to the time and space for this variant, and then we'll ask the second follow up.
Okay. So I guess the time complexity, so I guess we're not only going through all vertices and edges, but we're also going through or yeah, I think we are going through all vertices and edges. So the time complexity, I believe, was fine as is. But I think the space complexity would have to be updated because the both or the scene data structure, which consumes a greater amount of memory, not only keeps tracks of the vertices, but it also keeps tracks of the vertices and the number of delays. So I guess this would be O of V, maybe times max delay, where delay is the maximum delay, which in this case was 2. So we're keeping track of all the vertices up to that max delay potentially, just because we're not only storing one instance of each vertice, but max up to max delay instances of each node or each vertices. Does that sound right?
How would you represent max delay as an input parameter?
Um, as an input parameter, that's, I guess, a good question. So I guess max delay would be up to, I guess, yeah, that would maybe be up to the number of vertices, just because in our initial example, we would have to go through every vertex to, or every node to reach that destination node. So
Okay.
then in that case, would it be O of V squared?
Okay. We can move on.
Okay.
All right. So the second variant of this problem is that now I'm going to tell you that you can assume there are no cycles, and
Okay.
then now I will also tell you that the edges have weights. So
Oh,
now,
okay.
in this variant, the distance between two nodes is not the number of jumps, but the sum of the weights between the two nodes.
Okay, so it would be the sum of the distances between two nodes. Okay. Um, okay, that's interesting. So I guess I should preface, I've never really experienced or seen a question on non-unweighted graphs. So how exactly would that be represented in the adjacency list? Would this just be a tuple where it would be the destination node and the distance from the source node to that destination node?
That would be fun for this problem. Yeah.
Okay. So I guess maybe you could just use the existing problem. Um, and then, sorry, I guess when someone asks a follow-up, do I just stay on the same problem or should I like have a new segment of code?
No, you can. Well, so it's good to ask. For me, I don't care. You can go ahead and just reuse the same piece of code because it won't
Okay.
be relevant anymore. Yeah.
Okay, perfect. Thank you. Okay, that's good to know to ask in the future. So I guess here it would just be, for example, like 3 and 5, and then maybe like 2 and 7, 1 and 1, and we can just, to make it easy, say 2 and 1, 3 and 1, and then we'll just say here 3 and okay. So I guess in this case, the source node would be 0, the destination node would still be 3, and then there's multiple options. I think in the example we set here, it would make most sense to go from 0 to 2 instead of 1, just because it takes 7 steps to get to 2, and then go to 3 from there. And then that would be a total sum of 0 to 2 is 7 steps, and 2 to 3 is 10 steps. So that would be a total of 17 steps or 17 delays. And that's better than 0, 1, 2, 3, or 0, 3, because 0, 3 would be 5. 0, 1, 2, 3 would be 1 plus 1 plus 10, which would be 12.
Yeah.
So I guess in this case, would this be the expected output for this example input?
Yes.
Okay. Um, so I guess if that's the case, I think we can maybe just keep the algorithm as is with that BFS since we're going through every node. But what we would have to do is we would just have to, I guess, have the instead of incrementing the delays by one, we would have to increment the delays by the number of steps. So I think if we think about it, the approach would still be the same. Still the same. Only variation is update delays increment to account for the wait. Do you think that would be a good solution to proceed with?
Update the delay. Only variation is to update the delays increment to account for that. So how would you update it?
So I guess here, like instead of saying delays plus one, we
Yep.
would say delays plus the second value.
Okay.
Okay. So should I go ahead with implementing it?
Yep. Go ahead.
Okay. So I think the queue would still have the source and the delays. The scene would still have the source and the delays. So this is the current amount of delays. And then here, this would include the neighbor and I guess you can say the distance. So we'll have to say delays plus distance. So for example, in this case, it goes to 3, then it checks is 3 and at a distance of 5 in scene, which it isn't. So in that case, then we would add that here, and then we would add that to the queue. So then this updates delays not with 1 every time because we assumed it was unweighted and uniform distance, but rather with the delay that we see in the weighted graph.
Okay.
As of now, I think that would work. Would it make sense to go through an example problem?
Yeah. Let's go to your example that you gave.
Okay. So I'll just copy and paste this again. So we have this example input, and let's see, what do we have? I'll just copy this really quickly. Okay, so we have a source of 0 and a destination of 3. And maybe to make this example easier, I'll just have something like this. Or wait, sorry. Yeah, I'll just have maybe something like this just to make it easier, I think. So we don't have to go through as many steps. So again, we start with 0 and 0. So I'll just say here 0 and 0. And then just copy this for the queue. So the queue is the same. Okay. And the max delay is again reset to negative infinity. So we pop a node and delays. So this would become 0. This would become 0. So check, is the destination equal to the node? No, it's not. So iterate through all the neighbors of 0. So check is 3 and 0 plus 5, which is 5 in scene. It is not. So then add that to scene, add to the queue. And we can do that for all the nodes. So I'll say 3, 5, 2, 7, 1, right, 1, 1. And then I'll add those to the queue as well. So then once we do that, we're iterated through all the neighbors of 0. And then we go back to the top of the queue. So at the top of the, and sorry, we did pop this earlier on. Okay, so once we have popped this, at the top of the queue is the 3, 5. So we check, so we pop it off the queue and update those member values, which is 3 and 5. So then we check, does it equal the destination node? Yes, it does. And set the max to the max between negative infinity and 5, where 5 would be the maximum value. Once that's done, we would iterate through all the neighbors of the current node in question, which is 3, and we check 3 doesn't have any neighbors. So this iteration would end with the node being 3 and delays being 5, and we would pop up the next element in the queue. So then this would become 2, this would become 7. and then you would see here, go through all the neighbors of 2. So for 2, we only have one neighbor, and then we check here, does 3 and 17, or yeah, 3 and 12, or sorry, yeah, 3. So the neighbor would be 3, and delays is 7. The distance is 10. So we check, is 3 and 17 and C? No, it's not. So we would add it here. 3 and 17. And then we would also add it here. 3 and 17. Once that's done, we've gone through all the neighbors of 2. So I think we're done through this iteration of the outer loop. We can proceed to the next one, which has 1 and 1. So 1, 1. So we pop 1. 1 is in the destination node. It doesn't have any neighbors. So we're done with this iteration. And then we go off with the next iteration. So this would be 3, and this would be 17. Once that's done, we pop that off the queue, and then we check, is this a destination node? Yes, it is. So then find the max between the max delay, which is 5, and the current delays, which is 17. And then that equals 17, so update max delay. And then go through all the neighbors of this node, which is, this node in question is 3. There aren't any, so we end this iteration, we go back to the top, we check, is queue empty? Yes, it is. So in that case, we would return the max delay of 17.
Okay.
Was that walkthrough correct, or were we
That's
missing
fine.
something?
No,
Okay.
that's fine. So does the time and space complexity change versus the original prompt?
No, I don't believe it changes, because all we did to adjust for this variation was just replace the 1 with the distance in the input, and again, C and Q before we're also storing the source and the distance. I guess while the time complexity might not change, the space complexity would change, because we did say it was V times the max delays, which was previously set to just the number of vertices. But actually, I think, sorry, never mind. Even this time, I think we could potentially go through every vertex as well, or we would have to anyways. So I think actually it would be v squared, because we would have to go through every vertex regardless of the distance, because we're trying to find the max delay, not the min delay.
Okay. All right, let's call it here.
Okay, thank you.
And then we will go through some feedback now. Some feedback, some questions.
Okay.
So I usually start these off, asking you, how do you feel about your performance today? What do you think went well, and what do you think didn't go so well, if anything?
So I guess since I have nothing to back it on, or like compare it to, I think maybe it went decently well. I guess I did forget maybe some of the syntax with where the libraries exist, and I think we made I realized some issues with like the Python fundamentals, like you can't have an immutable string or an immutable or a mutable type, sorry, for the hash map, and also I wasn't sure with how to change a character to lowercase. And then I guess I guess I didn't ask this verifying question of the weights when you initially presented the problem, so I guess I maybe missed some assumptions or clarifying questions that I made, but I shouldn't have assumed without asking.
Okay.
Um,
Yep.
and then I guess, I don't know, I felt like maybe the walkthroughs were a bit slow, but I wasn't sure into how much detail to go into, because I felt like for the first one I skipped a lot of detail, and then I think in the second one I like walked through it completely, so I
Yeah.
wasn't sure what to do.
Yeah, for sure. I think that's a pretty accurate assessment overall.
Okay.
I'll go over some notes I took as well, and we can chat about that. And you're free to ask any questions as well. It could be questions about the feedback. It could be questions about the problems. Anything. So,
Okay,
so whatever you kind of see fit there. So I'll start with question one. So question one, obviously, this is a pretty simple problem, but the main thing here, I saw you brought your approach, your umpire approach. I think that's fine. One thing
okay.
I will say is that I think you did have a pretty good read that some of your walkthroughs were too slow, right? And what does that really mean? Like, what it means for a walkthrough to be too slow is if you believe that the interviewer, or you believe that you already have high confidence in the algorithm, you can save time by doing a faster walkthrough with a simpler case, or by getting buy-in from the interviewer to check if they even want to walk through. Right. The main thing there
Okay.
is just that sometimes, especially if it's a simple problem, it's not meant to be very rigorous. Then
Mhm.
it doesn't really matter. Well, then the walkthrough matters a lot less.
Okay.
So don't. So I would say what I mean by that is, yeah. So the walkthrough they were okay, but you're definitely err on the side of too long. And what that
Okay.
means is that you're robbing yourself of time to maybe do some more questions. That's the kind or
Okay.
any follow ups interviewer might have, right?
Right. Okay.
So group anagrams, I think that walkthrough was fine, but
Hmm.
you probably could have saved time. You probably could have saved time in the first place by just asking, hey, do we want a simpler case, etc.
Right. Okay. That does make sense. Okay.
Okay, let's take a look at that. So yeah, I think a positive thing again. Good to check assumptions. Good to check inputs outputs. Now for the first question, you actually did ask, what if the input list could be empty, and it could, and you didn't actually specify what the behavior there was. So that's one
Oh,
thing.
okay. Yeah.
So one thing you just didn't follow up on there.
Okay.
Um, Regarding not knowing the import or not knowing the is lower function for character, I think most interviewers will let it slide. But
Okay.
I say this every time, right? But if the position is looking for Python, that's gonna be a cause for concern. If
Right.
you're using
Okay.
Python just for interview, that's fine. If they actually require Python skill, then that's gonna be a negative.
Right. Okay. That's a good point.
Okay, question. So question one's pretty whatever. Any concerns about that, or move on to question two?
No, I think that was very helpful feedback. Thank you.
Okay, question two is pretty straightforward as well. So this problem was, this is a very like you identified. This is a pretty standard graph search, right? Pretty standard graph search problem. Now, the approach you took for the first question was, I think, overall good. However, I don't think you're very familiar with the graph structures, and the reason I say that because there was a key assumption which you did not clarify, which is that the graph can or cannot have cycles. Right? If
Okay.
the
Yeah.
graph can have cycles, there cannot be an answer because you would just enter the cycle forever. So this
Oh,
is
okay.
this
Yeah.
is this is a that would be considered like an error, right? So
Hmm.
you didn't specify that. Now, of course, you had the scene set, but the scene set doesn't do anything. I didn't say you can't go to the same thing twice. I never said that.
Right. Yeah.
Okay, so that
Okay.
would be considered an error on that front. Okay. Um, right now the weights. So the weights. So like I said. So like you said, you didn't ask about the weights. That's not necessarily an issue. Typically speaking, now of course you should always ask about it, right? So whenever you get a problem about a certain input, there should be just a checklist of questions you ask. Right? You had this for the strings, right? List the string input. Can the list be empty? Can the strings be this character? Can the what character set? Right? So these are automatic questions you ask. Should be the same thing with graphs. Graphs, boom. Do the edges have weights? Boom. Are there cycles? Boom. Can they be negative weights? These are immediate things you should just be asking, like just automatically ask them, regardless of the problem is about. If the question involves a graph, these questions should just be coming out, right?
Okay.
It's a
That's good to know.
cost benefit analysis there because it takes so little time to ask it and write it down, right?
Right. Okay. That makes sense.
Now now aside from that, obviously the problem was pretty. I mean, it was well solved, right? So BFS makes sense. V plus D is correct. The space complexity there, yeah. So you did cache that. Yeah, you are storing every possible edge, and because cycles are allowed, that would be V squared. But
Right.
if but like I said, so that's kind of where that is. I think you're actually correct on that one, but the space complexity there, you got to be careful, right? If you're starting out with max delay, yeah, that's correct, but what is the max delay, right? How many times are you tracking the delay? So
Right. Okay.
that's something you just got to be just got to be cautious of.
Right. Okay. That's very good to
um,
know. Thank you.
right, so okay, but otherwise the implementation was fine, the walkthrough was fine. The second time the walkthrough was also pretty good, but like I said, like you said, right, it's a bit slow. You should check in, do we really need to do this, what detail do we need to do this, and can we simplify that test case even further? Right, and you caught
Right.
yourself
Okay.
on that one on the first walkthrough for the second problem where you simplified the test case, right? That was good. But if you're
Hmm.
doing that in the middle of the problem, you kind of already missed, right? You should have done the beginning of the
Right.
walkthrough.
Okay.
Yeah. So second variation, obviously this one. So this one, yeah, negative. So it can have weights. It can have weights. One thing you didn't check, and it wouldn't matter in this case, but you didn't check is right. If the weights come in, you got to ask, can they be negative? Why is that
Right.
important? The reason that's important is because uh, whether or not you have negative or positive or negative weights or positive only weights, that determines what algorithm you can use, right?
Right. Okay.
So that's going to be important. Now this is probably using BFS anyways. BFS works with always. That's fine, but
Okay.
that's not true necessarily for other graph algorithms.
Right. Okay.
Right. So you got to so like these questions just have to come out.
Okay. Good to know.
All right. So for practice, you should. I mean, obviously, go back and form the questions for the graphs, and this should be true for. So like for example, if a tree question comes out, you should have automatic questions about trees. Right. If it's a heap question, come on that. If it's a pointer question, come on about that. Right. So like no matter
Right.
what kind of question it is, you should just have probably like like 2 to 5 questions that just are that just come out immediately for that.
Right. Okay. That's very good to know. Thank you.
All right. The only other thing I will say is about yeah. So we did run out of time for the second follow up. The This was supposed to build up to the real question, which was, um, how would you solve this problem? But the destination node is every node. So can you find the longest node between a source node and all other nodes? That would be
Oh,
like the
okay.
real question, which would be a medium difficulty question. Right. The way
Right.
it's asked right now is fairly simple. You could Some people might say it's a hard or easy. Some people might say it's an easy or medium. But the real
Mm-hmm.
medium question here would be what is the write a function that finds the longest path to all nodes given one source node. So you could do that for
Right.
homework.
Okay. Yeah. That would be a good idea. Thank you. Okay. Um. So thank you for all that feedback. Would you say like with the umpire framework that I learned, like was it into too much detail? Did it eat too much time? Should I have spent more time coding, less time planning, or vice versa?
So I think that would be something which you have to read depending on the type of interview. I'll give you an
Okay.
example. So if you're going for an interview like let's say it's a Meta Loop or Amazon Loop, they're going to be asking two questions, two mediums. You can assume it's two mediums or one medium, one hard. You really won't
Mhm.
be asking you if you get asked two hards, that's unlucky. Don't plan for that.
Okay.
You should be planning for one medium and one hard, and you
Okay.
realistically be asked two mediums. If you can't use the Empire framework to solve one medium and one hard in 50 minutes, it's either the framework is too slow, you're it's being held back too much, or you're not very familiar with the framework. You don't know where to cut the corners. So I
Mm.
wouldn't be quick to kind of blame the framework either way on this kind of thing. But or like like even if you didn't have the umpire framework, you still should do walkthroughs if it's a difficult problem if you're not sure about the edge cases, right? But
Mhm.
um, either way, either if you use this framework or another framework, you have to be able to solve one medium, one hard in 50 minutes if that kind of accompanies your goal, right?
Right. Yeah. I guess yeah. My current technical ability is far from that. Now, if these were easy questions. Okay. So yeah, I guess that's good to know. And then I guess for my example walkthroughs, since they take so long, do people usually with walkthroughs walk through multiple walkthroughs, like multiple? I guess as you just mentioned, edge cases.
The main
Is
thing
that
here
something that should
is
be done?
yes. The main thing here. So the real purpose of the walkthrough is twofold. The first thing is if the interviewer is not convinced you are correct.
Okay.
So they will make you walk through it because they want you to find the bug. That's the first reason. The second reason, well, I mean, and that's the most common reason
Yeah.
because the fact of the matter is that most interviewers know all possible ways to solve the problem. They don't actually like they know if it's correct or not. The second reason is sometimes because they want you to check an assumption. So it's not an implementation issue. Is that they want to check your problem understanding issue, which is that you have not made a correct assumption, and they want you to
Okay.
walk through it to detect that the problem is not like the problem you're solving is not the problem that has been asked. So generally speaking, you won't be asked to walk through questions at a high detail. They'll be asked to just say, do you think it's correct? Okay, we're moving on then. So so more often than not, what I'm saying is, if you don't think there's an issue, if you think there's an issue, then you should walk through it so you can fix it yourself. If you don't think there's an issue, then you should ask them, hey, I'm convinced this is correct. Do you think so? Can we move on? Or do you want to walk through?
Okay. So if I don't think there's an issue, then ask them if they want to walk
Yes.
through. If I think there might be something wrong, it's better if I say I think we should do a walkthrough to confirm if it's correct.
Yes. Exactly.
Okay.
And you
Okay.
should make yourself a test case which proves or disproves that concern. So, for example, right, in your test cases, you didn't have any cycles, which means that you either don't know about
Right.
cycles, which is unlikely, or you just didn't think that that could be part of the problem.
Okay. Yeah. Right. That's a good point. Okay. That's good to know. Okay. Thank you. Um, okay. Yeah. Thank you so much. Yeah. This was incredibly helpful. Thank you so much for doing this for free. I know other services charge you an insane amount of money for mock interview, so I really appreciate all this feedback. Thank you so much.
No worries at all. Cool.
Okay.
Thank you for participating.
Yeah,
Take
thank you
care.
so much for doing this. Okay, bye.
Bye bye. All right, moving to the next guy. Let's take a look here. Let me call him up. Let me call him up.
Hello?
Hey, can you hear me?
Yeah, I can hear you.
Great. Let me just give this guy his stuff. All right, great. I'm gonna invite you to this coder pad, and then we'll go from there.
Sure, sounds good.
Oh, I just did something bad. Oh, it doesn't matter. How does this work? Boom. Okay. Let me know when you're in.
Okay. Okay, I'm in.
Yeah, sounds good. All right. What question did I ask you last time? Wait, what did you want? You were looking at this thing. You are new grad hard. Is that correct?
Yeah, I actually I noticed the form kind of changed from the last time I did it, whereas like now it's everything's either like easy or hard at like the various levels. So I wasn't too sure, so I just picked like new grad hard.
Okay.
Um, don't know like what the definition of hard at the new grad level is, so but
That's actually that's actually part of the exercise.
oh shit.
Yeah, because if you're going for new grad hard, you should be knowing what's going on. But like if you're prepping, but you prep for new grad hard, right? If you prep for something else, we ask you something else. But like, did you prep for new grad hard?
No, it's like before it was like only either easy, medium, or hard. Like it wasn't
Yeah,
that granular, but
yeah. I got rid
I
of
think it's
medium because everyone's
fine.
picking medium, but medium actually doesn't mean anything because there's not enough granularity between, for example, intern hard and new grad easy. Like, what's the difference? So
Yeah.
I got rid of it. I only put two extremes because people should either be saying that, oh, I'm new to this, I want to know what's going on, or I want to actually get grilled on this thing because everything else is worthless. But
Oh, okay,
okay,
okay. In that case, I think I made the right choice then.
okay, all right. And I saw you in the chat earlier. Was that you? Was that you? Was that you
Yeah,
chatting about
yeah. I
this
was I
problem?
was watching along.
Okay,
I'm
great.
curious,
Have
like
you
what
have you done
level
this
was
problem? Uh,
those problems that were just
that guy.
done?
That guy said that guy was new grad medium. He said medium, but I think he has a custom field. But new grad medium for
Oh,
me
okay,
is I just put it as like that one would be. I mean, like those guys were pretty standard easy.
okay.
Like the lead code
That sounded
mediums, the
about
lead
right.
code mediums, but they're considered easy for a new grad.
Okay, yeah, that sounded about right.
Okay, then we'll just pick up where we left off then. So let me go ahead and get set up here. Make sure my recordings are good. Okay, great. So I mean, yeah, welcome back, repeat guest on the mock interviews. Now, so you saw the previous problem about the graph, right? I assume you
Mm-hmm.
saw that. Okay, great. I mean, look, I mean, we'll kind of ease into it. We'll do the same problem, but we'll pick up what they left off. Okay.
Oh, interesting.
Okay. Yeah, because I think it's a good problem and it didn't give any hints on it. So this for this problem, okay, I want you to write me a function
Okay.
called find longest paths. Your input is going to be a graph that's represented with your choosing that has edge weights
Okay.
and a source node, which is guaranteed to be in the graph. Oh, by the way, oh yeah, okay. Is Java your preferred language? I didn't ask. Sorry.
Yeah, yeah. I'm. It's still my preferred language, even though
Okay,
I'm trying to like transition to Python. But for
okay.
now,
I forgot to ask. Sorry. That's fine. That's fine.
that's okay.
All right. So yeah, I'll start from the beginning. So I want to write me a function called find longest paths. It's gonna take in a graph that's represented any way you like, and this graph has edge weights.
Okay.
And then you're going to be also given a source node, which is guaranteed to exist in the graph, and you are to return a list of the longest paths represented as every path from the node or the source node to every other node, the longest path.
Every other node. Okay. Is that all for the description?
Yep.
Okay. Cool. So for this problem, so you said the edges have weights, and is this a directed graph or undirected?
This would be a directed graph.
Okay, so I'll make a note of that. And is there any particular like format for the input, like whether it's like an adjacency list or like a just list of edges with weights, or can I just
Sorry, can you repeat that?
yeah, no worries. So is the inputs an adjacency list, or could it be just an list of edges with weights, or
It could be any way you like to represent it.
anyway? Okay. In that case, I'll just represent it like how the previous person represented it, which is just an adjacency list.
Okay.
Okay, and then we're after the list. Our final answer should be a list of the longest paths from source to every other node. Okay. So another assumption I'll make is like the nodes are just represented by integers.
Okay.
Um, so that if we're given a graph with n nodes, then the nodes will just be labeled from 0 to n minus 1. Um, and you said we're after the longest paths from the source node to every other node.
That's right. Yeah.
This kind of sounds like Dijkstra's. We could use like Dijkstra's, but like maybe a modified version of it, because in like the typical Dijkstra's algorithms, it's actually finding the minimum path from a given source node to every other node. But since we're trying to find the longest path from the source node to every other node, my thinking is just that we just need to make some slight modification to that algorithm.
Okay. Okay.
So I'm just gonna go off of like what I know about Dijkstra's and then like make some modifications on the spot. I think I'm just gonna write out the signature for this. So I'm gonna call this. This is going to return it'll be a list of integer find longest paths, and then it's gonna take it's gonna be an adjacency list. So it's gonna be a list of integer. Let's say graph. Okay, and I assume like I just want to define the like how this list of integers is gonna look like. So um, the nodes are gonna be labeled from 0 to n minus 1. So that means the first element of this outer list is gonna be a list of node zero's neighbors. And what that could possibly look like is like it's gonna be like maybe node 0 will have node 1 as a neighbor, and then its distance is like 4 or something.
Okay.
Actually, this is gonna be more like and then it might have like 2 as a neighbor, and then the distance is 3, and then that's for node 0, and then for node 1 it could be that it has an edge to node 2, and then distance of 1. Gee, this is like this is actually more nested than I thought. So this is gonna be like a of no, it'll be like a list of I guess it could be like int arrays, right? Because like and this is kind of like complicated, but the int array here is just gonna be the neighbor of a node as well as the weight, and then this the next outer list is just gonna be the list of those neighbors, and then the outermost list is just gonna be the list of nodes, if that makes sense.
I think that makes sense, and it's up to you to
Okay.
decide if you want to represent it this way.
Okay, yeah. Okay, so Dijkstra's. I was just reading. Good thing I was just reading recently enough about Dijkstra's that I think I can kind of remember it. But
Okay.
um, Yeah, I'm just trying to like recount, just to recall it. Just give me 1 second. Yeah, so I know that you it uses a distances array, like to keep track of the distances from the source node to any given node. So distances, and then n is the size of the graph, or like the number of nodes. So and then in Dijkstra's algorithm, the distances from the source to all the other nodes are initialized to the maximum value an integer could be. But since we are finding the longest paths rather than the shortest paths, I think we should initialize, we should fill the distances array with negative, like integer dot minimum value rather than integer dot max value, just to start off with. Wait, why is this? Oh, it's just that I don't have a, I'm not returning anything so far, so should be fine. Let me just think a bit here. Um, yeah, I think yeah, the next thing that we need to do is like initialize a priority queue to keep track of um, the current distance from the source node to the every other node. And this in Dijkstra's algorithm, it's normally a min heap, since we're trying to minimize find the shortest distance to every other node. But since we're after the longest paths, I think we could use a max heap to store the distances to the current distance from the source node to every other node. Um, and then this will be a priority queue of uh, integer arrays, where the integer array being stored is the node, so like the node as well as the distance from the source to that node. So and then the thing that we are comparing, we are using to compare these integer arrays is actually the second value, which is the distance from the source to that given node. So it will be, we'll need a comparator function. I think we can have put a lambda function here where it's like, I think it's like a, b, and then we are just comparing the second or the value at index 1. So it'll be a,
Okay.
yeah, why is there a red squiggly line here? What is wrong?
Is it just a semicolon? How does this work?
I do that.
I think we do that. You have to write return, right?
Yeah, but if I don't write return, okay. Oh, now it's gone.
Okay.
Now it's gone. Okay, fine. Yeah, and then yeah, the thing we do is we first add the source node to the priority queue, and then the distance from the source node to itself is obviously just 0, right? So oh, and I forgot to define like the source node up here. So I assume like we're given the source node, and that'll just be an integer.
Yeah, that's fine.
Okay, so yeah, source, and then as I said earlier, the distance from source node to itself is 0, right? And then basically we will continue running this algorithm while the priority queue is not empty. What we'll do is we need to pull from the queue first, and then so it's and then the node will be the first value, and then the distance will be the, or I should say cur distance is equal to the second value. Right. And then what we need to do is compare that, compare the cur distance to the value in distances in the distances array for the current node to see which one is bigger. If the current distance is bigger than the one in the distances array, then in Dijkstra's algorithm for shortest and for longest path, I think we should update the distances array. Like if per distance is actually bigger than his node. So if cur distance is bigger than distances indexed at node, then that means we have found a longer path than the path that was currently in the array. And because we're after the longest path here rather than shortest path, we should update the distances node with the current distance. So then it should be that distances node wait a sec. feel like I might be doing something wrong here. 1 second. I think before we do this over here, we can check. We can check if the current distance is shorter than distances indexed at node. In that case, um, we don't need to do anything, so we can continue. But then otherwise, I think what we need to do is for the current node, we need to check its check the distance from the current node to each of its neighbors, and then add that for each neighbor. Add the distance from current node to its neighbors, and then see if those distances should be used to update the distances array. So this will be list of. So what I'm doing here is I'm checking the neighbors of current node. So wait, what is wrong here? Graph dot get. Oh, this should be just an integer, an int array, I think. And this should be cursor. Oh, actually just node. Yeah, so actually this will just be edge, and then the neighbor will actually be the first value, and then the distance. I should call it weight, I guess. Weight is equal to, and then the new distance will be current distance plus the weight. So that will be this new distance will represent the distance from the source node to this neighbor right here. And then what we need to do is check if this new distance is greater, if it's greater than the distance in the distances array. In that case, we would need to update the distances array. So is greater than distance. Then we will need to update distances array. Yeah, and then we would need to add new this new integer array to the priority queue. So it would be the thing we would add is the neighbor as well as the new distance. Right. Right, and then we keep on doing this until there's nothing left in the priority queue, and then at that point, there should be at that point the distances array should be filled with the values representing the longest path from the source node to all the other nodes. So then we should return distances. Actually, this should be distances is an int array, right? Yeah. Yeah, so I think this is just Dijkstra's algorithm, but just with some slight modifications.
Okay.
Go ahead.
So, okay, I think I understand your idea. Okay, I think I understand your idea. Can you explain a little bit about under what condition you add neighbors to the priority queue?
So basically, if the the distance that we calculate here is greater than the distance that we currently have. So like the distances array just represents the distances that we found so far from source to all the other given nodes. So if we found a distance that's greater than that, then we should update the distances array.
But this distance, the current distance you're comparing to, is that the so that's the best distance seen by any node right now?
Yeah, so the distances in the distances array represents like um the best or like the longest path so far.
Okay. And can you talk to me about how you guarantee that all the distances will be filled out?
Oh, let's see. Can it be guaranteed that all the distances will be filled up? I think it should be, except in the case where the graph, if the graph is not connected, then it could be possible that you cannot go from the source node to like some group of nodes within graph. And if that's the case, then since we initialize the distance array to be filled with integer.min value, then if by the end of this algorithm we still have like an integer.min value in distances array, then we know that it's not possible to go from source to that given node.
Okay. So you're saying that as long as a piece is connected, it's guaranteed to be filled in.
I think so.
Okay. I won't do an example here. Let's just go through the time and space, please.
Okay. So I think in terms of space complexity, we are storing the distances array And the length of distances array will just be the length of the number of, oh, will just be the number of nodes we have. So that's n. And then in the priority queue, we are storing the edges, basically. Um, yeah, we're storing the edges, and then yeah, so the maximum size of the priority queue theoretically would be just the total number of edges um, in the graph. So that would be it. That would be the number of edges, and then what else? I think that's it. So it would be the number of nodes plus, and the number of nodes because of the distance array, and then the number of edges because of the priority queue. So it would be number of nodes plus number of edges for space. And then in terms of time complexity, I think the bottleneck would be here in this while loop.
Okay.
Okay, let me think about this. Time complexity. So while this is not. So the maximum size of a priority queue is the number of edges. And then on each iteration, we are polling and then doing a check here. And then for each neighbor of this given node, we might add that neighbor to the priority queue.
Yep.
Oh, okay. So it is possible that for each vertex, we're adding all of its neighbors. So I guess like yeah, in that case, I think it would also be v plus e, where v is number of vertices and e is number of edges. Yeah, and since this is this while loop is the bottleneck here, the time complexity should also be uh, number of vertices plus number of edges.
Okay. So, do you want to write that down just as a comment above
Oh,
this?
yeah.
Yeah, yeah. Okay. Oh, yeah. Okay.
Yeah.
Okay. Yeah. Looks good. Um, and okay. So, okay, I'm happy with that. We can move on. Actually, before we move on, just for my consideration here, um, does the problem change if it is a undirected graph?
If it's an undirected graph, let's see here. I think the way I would solve it would be different because there'd be no need for a priority queue because distances are. Oh, sorry. Never mind. You said undirected, not unweighted.
Yeah,
Sorry about
undirected.
that.
Yeah.
It's undirected. Let's see. So if it's undirected, I'm just trying to think about cycles. Cycles could exist in both cases, right? So,
Yeah.
um, my gut instinct says no. But I'm just trying to think why.
No, as in it's there, like there's no difference, or no,
Yeah,
as
yeah,
in
yeah.
okay, okay.
Uh, yeah, because like the difference between directed and undirected is just that it's like which nodes you can visit from a like undirected graph is literally just a subset of directed. No, directed graph is just is a subset of undirected graph where you can go back to your you might not be able to go back to your parent. So because it's a subset, then I think if you're going from like directed graph to undirected graph, the conditions in which you solve the problem should be loosened because directed graph is just a subset of undirected graph. So that's why I think like there would not be a change here.
Okay.
Uh, yeah, I cannot. I don't think I can formally prove it right here,
That's fine.
but
Okay. No, that's just for intuition. Okay. That sounds good. Let's move to the next problem then. So the second problem here will be unrelated to the first.
okay.
Okay. This problem is called merge intervals. So in this problem, I would write me a function called merge intervals. The input is
Okay.
going to be an array of intervals, and an interval, a specific interval, is a too long array
Mhm.
containing a start and end number.
Yep.
And then you are to return a list of intervals as well, where there are basically as few elements as possible because you have merged all relevant intervals.
Okay, I see. Okay. Um, in the definition of an interval, is it guaranteed um, that the first value of the interval is smaller than or equal to the second value?
No, not guaranteed.
Not guaranteed. So it could be the case that we have an interval like 2 and then 0, right?
Yep, that's a valid interval.
As well as like 1 and 1 like 4. Those could exist in the same input, right?
Yep.
Okay. Because I was thinking like if yeah, that might make it a bit harder. We want to merge these intervals, and are the would we merge an interval like this, or two intervals like this? So if the first one is like 0, 4, and then the second interval is like 4, 6, would this turn into 0, 6?
Uh, yes, I would.
Okay, so it's like the bounds are inclusive.
The bounds are inclusive. Yep.
Okay. Hmm. Yeah, so I'm just going to define the signature first. And we're returning a list of intervals. So it would be a list of integer. And then the thing we're given is also a list of integer. Okay. I think it might be useful to like sort the intervals by either like the start time, like the first value, or aka like the start time of the interval. Because I'm thinking if we don't do that, one way we could solve the problem via like brute force is literally just iterate through the list of intervals, and then for that given interval, just like sweep through the rest of the list of intervals, and then see um, and then just build up the resulting interval from all of the intervals that can be merged with that interval. And then once we have that uh, like big interval, we can just like add that to the end of the list again or something. That seems kind of inefficient. Um, I think one thing we could do is sort the list of intervals by start time from in increasing order. After we've kind of fixed the input so that we don't have cases where we are like the start time is actually greater than the end time. I think if we do that, then one thing we could assume is that because all the intervals are sorted by start time, once we've merged all the once we've merged all the intervals that can be merged with the interval at index I, we don't have to like worry about we're guaranteed that like no other intervals can be merged with the interval at index I because they are they are sorted by start time. I don't know if that made any sense, but basically, I don't know if I should just give an example or if I just code it out and then like walk through a test case. I think I'll first code out like what I mean, and then I'll maybe if I have time walk through an example.
Okay.
Yeah. So to clean the input first, we need to make sure all the intervals are they have the start time at the start time is less than or equal to the end time. So basically, for this integer in we need to check if the first value is smaller than or equal to the second value. If it's actually greater than the second value, then we just swap them. I think we would just like create a new list of intervals for like the sanitized input. So list. Yeah, so here if the first value is bigger than the second value, we need to swap the two and then add it to new intervals. So I wonder if we can do something. This might be a situation where I'm not familiar with the syntax. Like, can you do like um, arrays dot as list, and then it will be interval dot get one, and then interval dot get 0. I don't know if that works.
I think the input that needs to be an array. No.
Oh, this needs to be an array.
I think you can just use
Okay,
list out of.
fine. See, this is why I need to switch to Python, because in Python there'd be like an easier way of doing this.
Yeah.
Wait. What's wrong? Interval dot get one, and then there's an extra. No,
Your new interval type is not correct.
right. Oh, right. Okay. Oh, shoot. As list actually returns in a primitive int array, whereas I want a list of integer. What's the other method for this? It's like
It's list out
list
of.
list dot of. Oh yeah, list dot of. Right. Okay, and then this is like uh, Appends the specify element and blah, 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 blah.
Okay, we can assume this works, and let's.
Oh my gosh. Okay, I'll come back to this later. Sorry. Okay, so assume here that after we've done all this, like the input is sanitized, right? And then now what we need to do is sort them by according to start time, I think. So it would be new interval dot sort, and then it will be the lambda here would be according to start time. So it would be a dot get 0 minus b dot get 0. Another sort according to start time. What we can do here now is iterate through the assorted list of intervals from 0 to the last index, and then we'll try to merge intervals to the current interval until we cannot do so anymore. At that point, we know that we are guaranteed that that will be the final interval in our list because we've sorted by start time. Yeah, basically that's what will happen. So for actually, I think this should be a for would be the other type of loop. Actually, we first need to initialize the first interval out here, so it would be right, and then this will now start at index 1. I would just call this candidate is equal to intervals get I. And then what we need to check if the candidate interval overlaps with current interval. And the way we do that is we check if the starting point of candidate is actually less than or equal to the end point of the current interval. So check if the starting point of the candidate is less than or equal to the endpoint of the current interval. If that is the case, then we need to cur interval. If that's the case, then we need to merge the two by setting the endpoint of cur interval to be the maximum of the endpoints of cur interval and the candidate interval. So this will be cur interval dot set. It'll be math dot max candidate dot get I, and then candidate dot no cur interval dot get I. Yeah. So that's the case if it does overlap. If it does not overlap, then we know that we can keep current interval as is and just add it to the result array. So yeah, so if this is not the case, then result.add cur interval, and then we set cur interval to be the interval at index I. So cur interval equals candidate. Is that right? Yeah. interval equals candidate. And then once we've done this, we've iterated through the whole array, we should be done. But we need to add the remaining, the per interval that's still remaining. So then results dot add per interval, and then we just return result. Okay, I think that is that's my solution here. Should I go over test
No,
case or
let's just go over this
time
time complexity quickly, and then we'll go to the feedback. Yeah.
Okay, so in terms of time complexity, we are sorting. We are like doing some sorting. And where am I doing the sorting? Oh yeah, here's sorting. We're sorting by start time. So that should take n log n time, where n is the size of the intervals array. Everything else is just a linear scan of the intervals array. So bottleneck is line 73. So in terms of time complexity, I think it should be n log n. And in terms of space complexity, in terms of what we're storing, we're just storing, here we're just storing the sanitized intervals, which is the same size as the original interval, which is n. And then over here, we are storing the result, which at worst will not get any smaller than the input. So space complexity should also be, it should be O of n, where n is the size of the intervals array.
Okay. Okay, that checks out. Let's go through some feedback then. Feedback and questions. How's that sound?
Yeah, sounds good.
Cool. I mean, how did you feel about either question?
I definitely felt the first one was harder, just because like the implementation of Dijkstra's algorithm is like kind of complicated and kind of something you need to have memorized. If you don't know like the proof of the algorithm, like in the back of your hand,
Yeah.
like the back of your hand. So yeah, the problem was definitely the harder of the two.
Yeah.
The second one, like I had the idea down, but I just like slightly struggled on the condition that the start time could be like greater than the end time. And yeah, no, I don't know. I knew how to solve this problem like pretty quickly, but it just like explaining what I was gonna do. Maybe I should have like explained as I was doing it to save time, but I think I was kind of running out of time to begin with when I started the second problem.
Yeah, it was low on
Because of
time
how
because
long
you,
it
you
took
spent quite a bit
the
of time with the first one.
problem.
Yeah.
Yeah.
Yeah, I did expect a lot of time to spend on the first one. That's not surprising. I guess I expected the second one to go quicker, right? I mean, like I knew you knew the
Yeah.
idea quickly.
Yeah.
That's not. I mean, it's obviously a simple problem, right? But
All right, and then like ran into like some syntax issues.
yeah,
Yeah,
syntax issues. Yeah,
over here.
exactly. Okay, well, like, yeah, I mean, let me talk about that, obviously. So, yeah, first question, I mean, as you said, yeah, this is just, Dijkstra's is definitely one of the ways you can solve it. It's a bit more, I mean, it depends on, like, what you're familiar with, what you can and can't do. What I will say about this problem is I think your approach, like, like, you got there, it's okay, but the approach could have been a bit smoother, right? So, for example,
Mm-hmm.
when you're saying, okay, I'm going to do Dijkstra's, it's like, okay, sure. Um, and then nothing's on the page for like 5 minutes, right? So what I'm getting at is you got to be more clear on the communication front for what you're currently trying to accomplish. So the notes I wrote, I said, you need a clearer game plan. So for example, Dijkstra's, okay. Dijkstra's, you know you have a queue, you don't know what the conditions are, you don't know what you might add, you don't know how to get the neighbors, that's okay, right? But just start writing some comments down, start writing some pseudocode down, so that there's at least something on the page, so that the interviewer could more easily help you if they need, right?
Okay. Yeah.
Currently, as it is, if there's nothing on the page, then there really isn't too much interviewer can do without jeopardizing some signals, right? So
Oh,
just a
okay. Yeah.
strategy there needs a bit of work in terms of just getting more stuff on the page first, even if it's wrong. So there's something that they
Okay.
have to look at, right?
Right.
Yeah. Another thing I will say is a bit. I think this is a bit of an autopilot thing. I'm not sure what the reasoning here is, but like you have a priority queue, which is correct for dextrose. Obviously, you have to have a priority queue. One thing I will say, right, is that you're doing increasing weights, right? A1 minus B1 is increasing weights.
Oh, okay. So it should be these two should be swapped,
It
right? It
should
should be
be
B
decreasing
my
weights. Yeah,
okay.
it should be decreasing weights. I mean, in
Right.
in actuality, like that's something which I would say is is like a conceptual failure. It's not like he didn't know that was the case. Like he knew that, but it doesn't need that they just didn't catch. So right, so that should be decreasing, right?
Okay.
I won't talk too much about the implementation. You can obviously say that yourself later on. But what I will say that you did also miss is the time complexity, which is incorrect. Do you want to correct it? Do you know where you went wrong?
Oh, time complexity. Hmm. Yeah, I was talking about like how this while loop is the bottleneck.
The while loop is the bottleneck, but
Um.
your analysis, let me take a look, of this is not correct. What is the time complexity of that?
Oh, party queue dot add. Adding something to party queue should be adding a single item should be like log of whatever the size of the party queue is. Right?
Yes, and what's the size?
Oh, so size is like um number of wait, is it? So size is just number of edges.
The size is number of edges, but it's you could be depends on how you're coding it. The way you code it right now, I think that's correct, but in general, it also depends, right? So like I mean, the way I would say is, for example, if you're talking about if we're talking about a more like a more quote unquote more regular Dijkstra's, then it would be like e plus v. Yeah, it'd be log v. It'd be proportional to the number of vertices, right? But the way you have it right now, I think it'd be log e, because that's the assumption we're making, that we overwrite the previous nodes with the new
Mm.
edges. But yeah, so I mean, so that wasn't quite correct, right? So you forgot the add factor there. So that would be some marks off on that, but I
So
think otherwise the
the
problem.
actual time complexity would be like uh, v plus e log e.
Yeah, it would be it'd be like this.
Oh, right. Okay. Because like the v plus e part is like the
That's how
outer
many
while loop.
iterations you
It's
do
the
basically. Yeah.
number of iterations of the while loop. But then the factor of log e it comes from this line over here, 146.
Yeah.
Right. Okay.
I will also say that like there's a lot of different ways to solve this problem. This is one of them. This is one of the pretty common ones. This problem, by the way, is actually adapted from the same exact problem, but instead of the longest path, find the shortest path. That's a very classic problem, right? Most
Yeah.
people know the solution to that problem, the shortest path problem. Um, a lot of people, well, I'm not saying you should do it this way, but what like this is a connection that you should be forming. Why is that connection there? The connection is there because if you want to find the shortest path in a graph, if you know how to do that, let's say, that is the equivalent problem as finding the longest path in the graph by just inverting the weights. So if you invert the weights,
Hmm.
then that'll be the equivalent problem. Now in this case, having the insight would have been a very strong signal, because that means you actually understand search very well, but it's not like a necessary condition. So that's something for you to consider in the future. And for you to study at home, go study the Bellman-Ford algorithm. That's the correct one to use in this case.
Oh yeah, I heard of that one, but I don't know the how that one works. So I'll definitely go check it out after.
Yeah, you can go resolve that problem using Bellman-Ford, and then practice on that.
Okay.
Otherwise, yeah, second problem. I mean, really not much to say. Your syntax was just off, but the problem is fine. I will actually quickly comment that like whenever you're fixing data, that's okay for your own sake, but like that's just an unnecessary pass through the data, right? Like, why do you need to fix the data? You can just have more logic in the comparator. You can just use that instead, right? And then over here, you would do the same thing. You would just determine the lower bound and the upper bound. So you have some more local variables, but that way you wouldn't
Oh
need
yeah,
to
I
have a
see.
linear
I see.
pass through the problem first.
Yeah, yeah, yeah.
But yeah, otherwise that's correct. Okay. Any other questions?
No, I think this is a really good eye-opening session about like what the kind of things that I need to work on. Thank you so much.
No worries. Oh, actually, one more quick thing I forgot to mention, which wasn't really a detail, but is technically still a thing, which is your time and space analysis is correct for the second problem, but your justification is not correct. It's not precise. The reason it's not precise is because the sorting algorithm, as you said, takes n log n time. That's correct, but it also takes O of n space. So it didn't matter to justify the space complexity using this array list as just the only source of the space. In reality, even if you didn't store the results, the sorting algorithm itself would also use linear space. So you missed that in your analysis.
Oh shoot, right. Actually, like, what's the algorithm that is used behind the scenes for sort? I'm not too sure.
For objects in Java, it's tim sort. For primitives, it's quick sort.
Oh wait, Tim sort. Okay, yeah, I gotta look into that Tim sort.
Tim sort is just merge sort with a more optimal base case.
Oh, okay, and then merge sort is it takes and is of n space, right?
And also the merging, which is, well, not merging, the merging of the call. I mean, just go study it.
Okay, yeah.
Okay, anything else?
No, I think yeah, a lot of good ground was covered. Thanks.
All right, then, yeah, thanks for joining. Take care.
You too. Bye.
Bye bye. All right, resume review time. Resume review time. Where are we? What's up, Leo? I was the guy last week that said I had an intern interview coming up. Oh, hopefully that went well. Hopefully that went well. New shapes. I don't want new shapes. I want text. I will be right back. All right, we're back. Okay, what kind of what do we have? All right, going for backend, but would take any suite role of offer. Previous experience is in SRE, but want to pivot to suite for next internships. I was wondering if we can. Okay. Let's take a look. Let's take a look. Oops. Let's do like this purple today. Pivot to suite next to internships. This looks familiar. Okay, let's take a look. That's fine. Relevant coursework, not too relevant. I mean, what year are you in now? I mean, you're coming on third year, right? You're coming on third year now, going to fourth year. You don't need these anymore. Okay, SRE, TA, SRE and TA. Linux computer networking architecture. Okay. Networking computer architecture. This is not justified. Where is this coming from? Computer architecture is usually not something that SREs work with. So this is unjustified here. I'm trying to read between the lines. I don't see anything here that would actually teach about architecture. It's on call, code analysis, system tracing. It could be related to that. I mean, experience is fine, but it might be overextending here. Where's my tab? Here it is. Nice, okay. It was databases. Then I will put databases there. Oh, through database administration task, performance student program. The database. Oh, do you mean? Okay, I think like, do you mean computer architecture, in terms of knowing the differences between x86, ARM, RISC-V? If you're talking about computer, like that's, if you're talking like retail grade computer architecture, I would personally leave that off. If you're talking about developing computer architecture skills in terms of configuration, that would be more appropriate. But I'm not too sure about this one either way. It's fine. TA. Three lines. Okay. 3 lines is a lot. Like, this point is pretty useless. But let's take a look. What else do you have? Okay, Bluetooth chat app. Kotlin Jetpack Compose. Okay. Oh, this has been going for a long time. This is good. Last point there is good. Okay. This one feels a bit too much like 310. Yeah, I think this one feels a bit too much like 310, but as a second project as well. Okay. This is like okay. Okay, but not great. Social media account finder. Oh yeah, I saw this one. Yeah. Okay, well, this is fine. This is good. Electric vehicle test. Oh, I remember this one. Yeah, this is fine. This is fine, but I mean, what are you going for again? You're going for pivot to suite. If you pivot to suite, this is pretty useless. But I think it's pretty cool. So maybe cut it onto one line. Put it on one line, you know. And like, if one line, then it's, you can see. Oh, that is kind of cool. So maybe Arduino's kind of cool. In terms of like suite work, like nothing here is that kind of in there, to be honest. What is this? Oh, intern committee. Okay. Okay. I think this is cute. I think you can put this on. I think this is a fine user space. That's fine. Okay. Oh, what do you say? Got your crash life should be Feb 2025. Yeah, that makes more sense. It is retend. Yeah, it's pretty obvious. Go to the points on the test bench. Try to convey the sequel. Oh, okay, okay. I think this is fine. I think, for example, I think you could just keep the first point on. I think that gives enough information, right? Like, for example, utilize register manipulation. Like, dude, no one cares for Sui, right? Like, that just doesn't matter at all. So I think that comes up in conversation. You can bring up the other two. Otherwise, you can put the first point in there just to talk about you use C, C++, and then, like a conversation starter. Okay, I think that's how you should approach it. So I'd say, okay, given this is the situation, here's what I would say. I would say, get rid of this point, add a point here to elaborate on the computer architecture if you want, or just add more technical information on the first point. This is kind of the main experience here, right? And then I would say this thing, for example, this point here is pretty useless. It doesn't really say, like, for example, you're saying enabling these features. But did you make these features? Right? Like, just enabling something doesn't mean that you made it. If you made it, then you made it. Then you should say so. If you're just enabling, that's kind of useless. So this point is kind of watery. This one is fine as is. I would keep this one as is. I would keep this one as is. This one you can cut down. This one you can cut down. Save room. Put some more points over here. Yeah, okay. I think that's about it. Would you give this interview came to Asana? Well, I don't review interviews. I don't review resumes at Asana, but this would probably get an OA, and then depending on the OA, you go through the phone screen. Okay, what's this? Applying to full stack backend roles. Haven't been aiming for a specific niche when applying for new grad roles. Open to most software development, except for things I obviously don't have experience in right now. Open to DevOps. Not many new grad out for that. Full stack backend. Okay. That's a lot of work to say I do full stack backend. Let's take a look. How many points do you say you should put on for Sui? I'd say 5 to 6 is okay. The thing is, that's your only experience. If that's your only experience, you don't have that much things to say about it. Definitely put 2 more points for SRE over talking about 310. Every single person in Western Canada knows about 310. No one's stupid. Nice, UFT. Hello. Love seeing UFT friends. Technical skills. See, split that up. Blah, 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 blah. That's fine. LangChain. Does LangChain have a capital C? I don't know. I don't use LangChain. Make C, make GP, get up actions. Okay. Yeah, I don't see that much CI/CD stuff here. I don't see that much CI/CD stuff here. I mean, there's this, obviously, but okay. So you're saying you're doing DevOps. You're open at DevOps. Okay, I see. Python microservice LangChain, user purposes. Okay, this is present. Oh, present for, is this like an 8 month? Or is this 8 months or is this pay? Oh, you have IBM. Wait, when do you start? Okay, so it's not pay then. Okay. Has stability, service, Dynamics production issues. Okay. I see. So these two are like these two are DevOps. Let migration of key functionality from agentic or X service from Legend to SG Lang framework. Okay. Intern. Been here half a year. Okay. Don't write foundation, retrieve content chat history. Okay, I see. This is okay. Let me keep reading. UT. This is UT. Okay. RA computer program. Okay. Fix the bug and react graph visualization. Logical. Okay. Let development of Docker file compose. So let to containerize front end, back end. Okay. I'm a bit confused with this. You let the development of Docker file. I don't know. I'm not sure it's the right word to use. How do you not just finish development? Like, was this multiple people working on the same Docker file? I don't know what's going on here, frankly. I think maybe the wording could improve here, but I think this is okay. I mean, yeah. Yeah, okay. DevOps, developer intern. So, okay, so you have a lot of DevOps stuff here. Compile technology, IBM, okay. Markham, okay. Clever custom team developer, PLX, compiler patch, COS, client development, okay. Okay. Good opener. Construction Grafana database, Prometheus. Deployed by Docker, monitor Jenkins memories, okay. Okay, so this is something else then. Monitor Jenkins memory, okay. Provisioned, convert Linux machines, bash testing mobile machines, okay. Okay. Sure. Bullet, pipeline Jenkins, okay. Linux servers, root system MD, cron jobs facility hosting, okay. Okay. This is fine. Right, this is okay. That's all. Yeah, I think. Okay, so here's the thing, right? So, okay, let me just get this stuff first. Courseography. I like that. It's good. QB store. This sounds like a school project. It's fine though. Smart socks. Red native. This sounds like a hackathon project. Oh, I like this. Documentation. Love to see it. Okay, so here's what's gonna happen. Okay, so this is obviously the bulk of your experience. What needs to happen here is quite simple. The first thing that needs to happen is you were here for a lot of months, right? This might have been your pay. I think the most impactful thing to do for this thing is to actually elaborate on what was going on at each of your critical kind of projects. So, for example, I would use the nested header method for this. So you have IBM, that's great, right? So you have IBM, okay, and then you obviously have the the critical PLX compiler patch. That's kind of the first thing. So and that's a lot of the kind of carrying a lot of weight here. So I would write PLX patch, right? And then put you probably need 2 points, maybe 3 if it's really important. All right, and then you have DevOps. Okay, DevOps, and then put 3 over here, right? That I'd say about encompasses it, right? So then you have your Grafana, right? Right? You have Grafana, you have Jenkins, right? Grafana and Jenkins you have together already, and then you had some systemd, cron, right? And then I say that this would clear this up a lot more. We're about to get rid of the room. I would say this thing get rid of 2 points. At maybe 1.2 points, it's okay. This point 1.2 point, it's okay. This I think is actually okay as is. It's a bit of it's related to the university. I think it's relevant in that sense. I'd say you can keep it as is. I would personally. Do you have a testing framework here? You have no testing framework here. So I would say I would get rid of jest and put jest over here. So you can save a point there as well. Okay. I think the content here is actually fine, but the organization, the priority is not there. All right. Let's take a look. Yeah, okay. Let's take a look. So this guy's comment. Looking for a full stack front-end, back-end, full-time jobs. New York, United States. Okay. Okay, so... Wait, what? I downloaded the same guy. What the hell? Hold on. Let me try again. Oh, I clicked the run download button. Okay, never mind. We good. Okay. Okay, here we go. Alright. Okay, so University, masters 3.8. Yeah, makes sense. I came from India, do a masters, makes sense. This is what? This is a bachelor. Bachelor, 3 point. What are you? You're going for what? Let me see. You're going for full stack backend. Get rid of this. Don't need that. Technical skill. Super like Golang REST super. Okay, it's no YAML flow. React.js. Mature UI, Streamlit, Fast API. Okay, no put pandas, lowercase. Okay. Okay. We have, so you graduated, not graduated yet, graduating soon. You have, that's 2 years, 2 years of experience. This is before you came to US. But also, but after you graduated, so this is probably Indian, okay. And then you have projects here, present, okay. All right, let's take a look. Global unit, okay, transfer product, economy, okay, it's fine. Okay, career, rest away from original optimize backend performance. Okay. Bit arbitrary. I'd say also, I just saw it right now, too much bolding, way too much bolding. I'd say cut your bolding in half. Could maintain over 25 RESTful APIs from boot, ensuring high performance. This feels like the same thing as this, no? Creating 40 plus US components and 25 RESTful APIs. So I think just duplicate that. Streamlined deployment with Jenkins CI/CD APIs deployments by 50% maintaining. Okay. Reducing deployment time, minimizing downtime. So none of this, besides just dropping the AWS, justifies minimizing downtime. Where like you have to actually do something to minimize downtime. If you said, "Oh, I'll minimize downtime by hosting AWS," that's not you. That's AWS. So that's not relevant to put there. Built complex data filters and interactive dashboards in React.js Spring Boot, improving data accessibility, seamless decision making, efficiency. Okay, Commander 600 same way ABC. Okay. Oh, it's in the US. Okay. Co-mentor. What does co-mentor mean? Do you have 2 mentors? 10-week. Okay. This last point feels a bit weird. I think it's okay to put in, say, you do some mentorship, but co-mentor feels like that's such a cop-out. Okay, safe trans, C2 Rust, translation. Improving software security and promoting memory stitch language adoption. Improving on software security. Okay. The last point feels pretty out of place. I think if you want to put it this way, at least talk about what you've used. So for example, you're talking about using AWS infrastructure, and you're doing some some code conversion with LLMs, right? Okay, great. Did you use Bedrock? Did you use SageMaker? Right, for LLMs. How did you host it? Did you use code deploy to host it? How do you test it? Right, like there's a lot of different ways to kind of test, and I would say like this last point, I think the idea maybe you started thinking about something, but as it's written right now, it has no content, so you got to improve that. Okay, e-commerce platform, backend code in GitHub, that's good. Does implement a full-scale e-commerce plan, JavaScript, root, RESTful APIs, user authentication, Google, 2 payment, Stripe. Advanced features such as calculators to enhance performance features. These are not features, these are products. Features not the right word for that. To enhance performance. Scalability, API efficiency by 90%. By 90%. Okay, it's a project, so no one will care, but that's a big number. People won't believe that, okay? JUnit 5 block MV. Okay, this is fine. CSC pipeline, AWS code, built to code, Pogo pipeline. Yeah, see, this is good. So this is what you got to do for this previous point over here. Right? This is good. This makes sense. Documentation, but okay, that doesn't matter. Okay, great. Distributed key value score. Coursework, Dynamo, Inspire, key value store, C++, and Linux. If you're sharding data, but Raft consensus. Okay, I like that. That's good. This 2 lines is about right for that. Podcast for support. Blah blah. Okay, that's fine. Okay, so I'd say yeah, the content here is actually quite good. I'm a fan of the content. Overall, it's just some small optimizations with rewording, reorganization. I think that's fine otherwise. And also you could consider bringing the technical skills to the bottom. I don't really care if it's at the top or bottom, but if you feel like you're torn on that one, and I know people are torn on it typically, if you're torn on it, just move to the bottom. It doesn't deserve the same real estate as like a project. Since grad 2023, being a full stack developer, government organization, do have internship experience designing, developing recommendation algorithms, so consulting framework, backend apps. 111 job, private tech company, which is more competitive. South Australia, okay. Still a backend dev. Got it. Vancouver, Canada, US. Okay. Okay. Okay, looks good. Okay, so redesign backend architecture claims enhance UI claims UI. This is ICBC, huh? Pressing. Okay, I like this. That's good. I think this is a good opener point. Right, good opener point. Talk about what's going on. Talk about some impact. Right, this is actually a relevant metric, which no one really cares about, frankly. But it's a relevant metric, so I think this is good. Okay, good. It's good. It's good. Good opening point. Created a BC photo ID renewal app using computer vision algorithms for on-device photo validation submission. Created a photo UI renewal app. I like that. This is good. That's good. You can get rid of the word algorithm. I would get rid of the word algorithm and write like Android or iOS or mobile or web. Right. That's missing right now. Well, it's on device, so it's probably mobile, but you didn't say. Improve CRUD task performance at 3x reduce caching problem integration. Okay, looks good. Blah blah, looks good. Reduce agile sprint durations by 20% by integrating automated Selenium integration tests into what? Reduced sprint duration by 20%. But automating Selenium regression tests into CI/CD pipeline. Okay, I'm gonna be with you. I don't understand how regression tests are supposed to impact the duration of a sprint. This might be some government sprint I'm not aware of, but I think just pick a different word there, and it's fine. Been on a team of 3 co-op developers, functioning bit of it. Okay. How long were you here for? Oh, okay, you're here for more than a year. Okay, this is good then. This is good. Yeah, this is fine. This is good. ML automation is this is what? This is okay. So a couple months there. Blah blah blah. Okay. Okay. First point's a bit watery. It's definitely not as good as the first point there. I mean, the first thing is like, okay, you built a recommendation algorithm, service architecture, makes sense. I love Lambda. Everyone loves Lambda. You transformed unstructured data, transforming unstructured data and transforming unstructured data into what? I think you're missing the word there. Okay, that's fine. Very similar to QRS. Explored and applied. Okay. Built a scalable cloud solution reducing option content percentage. Okay. High concurrent. Better to quantify that, but that's 2 years ago now. That's fine. Build robust SAP plans, get actions. Okay. But Git actions, do you mean GitHub actions? I'm not aware of like Git actions. I think you mean GitHub actions, yeah. That's fine, yeah. And also just in general caution against using adjectives. Someone like me who's in the industry using GitHub actions, like GitHub has a terrible SLA. Like they had been down like twice in the last month, right? So don't use the word robust to describe GitHub. It's not robust. That's fine. This point you can get rid of. You can consider getting rid of that. Now it's a startup which adds more validate, like adds some weight to this claim over here. But in general, if you're going for private company, going for a bigger company, that's not going to matter as much. Well, I mean the skill matters, but you can't prove the skill as such. So I would consider getting rid of that. Application engineer intern, 30% reduction in claim funding time, controlling automated, blah, blah, blah. Okay, that's good. Real-time learning system, data trace. Okay, that's fine. Protecting QAPM FA system. Improving claims workflow, automated security. Okay. That's fine. Software engineer developer intern, welcome to Amazon. Or I guess Microsoft's also Vancouver. Kinesis, oh, okay. Okay. MTTR, good. And this has been a strong point of the resume. A lot of the data points are quantified using industry standard stuff like NPS, MTTS, etc. Machine learning models, predictive okay, okay. Please device system, blah 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 blah. Demo cares. Okay, great. This is fun. This is fun. Yeah, I think this is the right way to model the projects. Like this right here is just perfectly good. Okay, what I will say is, oh, GitLab. That's probably what we're referring to. If you're talking about GitLab, then you should put it in. I think GitLab might be more reliable than GitHub, but I don't use GitLab, so I can't comment on that. Okay, right. This person's going for private. Yeah. Okay. So I would say this is on the right track to success. The main thing that I would be looking for here is looking for more breadth of work. Like this, and by the way, this is not really resume advice at this point. The resume, by the way, I think is just fine. I don't think this resume is going to hold you back. But just a wider scope of advice, I think what's really going to help you here is if you can find more work that aligns with the goals, right? So I'll give you an example. An example of that would be helpful is if you found, and let's be real, right? We're staying in Vancouver for a second, right? We have Microsoft, we have Azure, we have Amazon, AWS, and Vancouver as well, right? Look for things that kind of leverage those skills that give you a bit of an edge, right? I'll give you an example. One thing that's not going to help. I don't know what this is supposed to portray, but that's not really going to help you for the same unit of effort, right? This can be perceived as helpful because like this is just general good things to do as a good engineer. This is good, right? Back-end work, you're talking about performance increasing, talking about integration, talking about indexes. That's good, right? So if you can find more work that leverages your skills in this regard, that's going to help you more than finding work like Selenium tests. That's not going to help you. All right, moving on. All right, this guy says, this guy says, got a machine vision suite internship, computer vision, upcoming summer. Want thoughts on how I should make space for it? Take up projects. I will begin applying for winter 2026, summer 2026 suite internships when I start the summer internship. Okay, let's have a look. Boom, boom. Damn, not bad. I say lowercase p. By the way, and I don't say this often, but NumPy technically has a capital N and capital P, but that one I see so like incorrect so often. I'm not even commenting anymore. Scikit-learn is also lowercase. Good, that's correct. All right, this is fine. Blah blah. Oh my god, I haven't seen Gazebo in a while. Power Platform. Is that a Microsoft moment? What is that? Okay. So you can add a computer vision. Now you didn't say what you want to do. You just said you're just applying next year. So it depends, right? Let me have a look. Embedded software. This is okay. This is just ended. C++, TCP/IP, Linux, Xilix. Oh shit. FPGA. Okay. Okay. I see Jenkins. Okay, I see. I think I know the company. Okay, that's fine. This is recent. This is so you had summer in school or something, or summer off. Java, Python, beautiful soup. Okay, this experience is not very good. Technology consulting intern. Okay. Power to make. Oh yeah, this is a Microsoft moment. Resume. Oh, capital. Oh, I like that. Okay. This can be cut down. So these two can be cut down for sure. Software development intern. Deploy merge stack. You don't have to explain that. Okay. You can combine these 2 points. Okay, so let's take a look at that's good. Let's take a look at this type. Okay, that's good. This is good. Okay, so want to add a new computer vision thing? Okay, here's what I would do. First of all, these two can both be 1 point each. I don't think this has much value. Here. Especially if we're talking about stuff like PowerShell scripting with like these proprietary technologies. Like this is just not relevant, right? So this is something which you can definitely cut down. I just spot check these 2 points and combine those 2 points. With that, I think you have enough room to at least start. Now, I would, generally speaking, try to not get rid of projects. Um, at like just in general, like I think the way you have right now is one line each. I think it's fine as is. If you really want to cram and save space, you can put them on the same line, right? So consider the fact that you have RTOS. That's great. I love the RTOSs, right? But you have C and STM, and they're like right here already, right? So just get rid of that and just put this. Just hoist it over here, right? Same with this, right? Like you can just hoist it over here. Now this one doesn't have all the technologies over here, but right, but you can put these technologies over here. You don't need them to list it per project, right? So you can save a couple lines there if you're really trying to cram in space. But I'd say start with cutting down the stuff over here. Not most of the stuff, especially if you have. I see some good experience over here, by the way. Some good stuff over here. Some decent stuff over here. You don't need to have every work get like filled out to that degree. So I'd say that's how you should save space. What should I do? Well, what should the cutoff date be for past? I'm assuming you mean past experiences. Should experience before 21 leave my resume? I would say if it's tech related, it should never leave the resume. If it's really not super related, but it's still tech, but what I would do is very simple. It's just put it as a one-liner, right? So I'm not sure if this guy or not, but just put it as a one-liner, right? So let's say this is like really old now, like you don't really care about it, it's bad experience. Let's say for example, right? Just put software developer intern, put the company name, and then just write one bullet point. That's it. I'd say most of the time it's worth showing that you have work experience going back that far, because that in of itself is a positive signal for applicants. All right. This guy's saying look for full stack roles targeting medium big tech companies. Okay. Okay. So Bachelor of Science Computer Science. Oh, BCS program. Okay, that's good to specify if you're in BCS. Okay, that's fine. Let's take a look. Technical skills. Boom, 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 boom. That's fine. Okay. We have we get two projects here. Okay, let's take a look. Two rad code based on type related errors. Okay. This is 4 months or so. 3 months. Improved maintainability client side loading performance factoring over. Okay. Right, so this is one thing I have to say, right? Especially with loading performance, like this is something you can measure, right? Chrome Lighthouse, your friend, Chrome Lighthouse. It's too late now to go back and measure it, but if you have data about that, you can put it in. Implemented 15 feature requests and bug fixes which improve development front end feature React managing. Okay, Redux, okay. Running updating REST APIs, type of ARM, okay. That's fine. Just pretty standard kind of front end stuff. Now you did say full stack. You did say full stack, but I'm only seeing front end. Right? These two are obviously front end. This one you didn't say is front end, so if you're using Node, for example, that would be back end, but you didn't say. Oh no, this is React. So this is full stack, but you only had front end. So if that's your title, just be aware people are gonna ask you the question there. Subject intern, okay. That's good. Okay, dashboard, CloudWatch, visual latency metrics, scaling plugin, troubleshooting production environments. Okay, like that. Okay, like that. Gained experience in deployment, blah blah blah. Okay. I would say if you're talking about deploy applications to EC2, you could talk about the process itself, like what is being used to deploy, what is a pipeline, what is a CI/CD framework, that kind of stuff, right? For example, if you're talking about Amazon pipelines, right? That's Amazon pipelines is still a CI/CD framework. Talk about learning about the blocks. Talk about learning the promotions, right? Like those are still things you can talk about, even internally, right? So that's that. So that could be relevant right there. Software development intern. 25 feature requests. Okay, this is fine. Yeah, full stack stuff like that. Selenium script perform. Okay, Selenium put at the bottom. We don't want C test. Full stack web app development. And so I'd say learned full stack web app. Just say developed some full stack using that technology. That's more active, right? Learn is more passive. Developed or did something else, right? If you show it instead of telling it, that's more active. That's better. Collaborate with company stakeholders. You check out a demo. Okay, sure, that's fine. In-memory database want to read us using RESP protocol. So okay, keeps memory match the replication. Okay, I think that's pretty cool. First place 15 university hackathon when, but working team of 4 develop a yoga training app can be arranged in Scorpio. Okay, develop a custom algorithm to provide media pipe. Okay, I think this is good. I think this is pretty good. That's fine. Okay, so I think the main thing here, right? What's your comment? Full stack roles, medium big tech. Okay. I think the main thing here is just okay. The resume presenting the current topics are fine. If your response again, this is the thing. If your response rate, because you're graduated, right? You're graduated a year. If your response rate is more than 3 to 5%, that should be time to do interview prep. Forget the resume. Do interview prep. If your resume is less, this is generally true for everyone. Not everyone. Almost everyone. If resume response rate is less than 3%, like you're not even getting non-auto OAs, you're not even getting to the phone screen, then to improve this thing, don't tweak the wording too much. Start making some more impressive full stack projects. So a full stack product would be the next thing to do if your response rate is less than 3%. That's kind of what I would say here. All right, this guy not redacted. How do people from the United States of America who speak English check that yes, I have confirmed I've redacted this resume, not redact the resume? Absolutely crazy. Okay, moving on. All right. So this guy's comment is trying to land a beginner software development internship. I had some intern experience, but I want to work towards getting a software developer role. Okay. Locality did not fill in. Okay. Work for Laurier, Bachelor of Computer Science. Coursework, data structures. What year are you in? You're in third year now. Third year. What courses do you have? You have this. Yeah, I'd say you should definitely cut this down to one line, but I would remove it if I were you. Okay. Connect to comprehensive business, blah, blah, blah. Okay. So, okay, so the first 2 points are not technical. Right, that's the first thing. So I would say this should be the first point. This is fine. Okay. Right. So if you since you have some technical experience here, this is, as I said, this is actually only the 1 out of the 4. Right. Okay, that's great. Leverage it. Put it first. Perform routine system admin tasks, including user management, security management, data management. Okay, that's a bit wordy. I would say including management of user security and data. Perform. I think your tense is off here. This should be performed, right, in the past. Conducted, past tense. Okay. Involve and track with business groups to gather. So right now, this is not clear what's going on here, right? You have interact with people to gather requirements. How did interacting with things increase efficiency? It should be like you interacted with it to learn about something, to implement that learning in your own system to increase efficiency. I think you're missing the action that you actually took to increase efficiency. Troubleshoot, support tickets across different NetSuite modules to optimize user adoption. Okay. Yeah, this one is definitely less technical. I would cut some points off of here. Like for example, this one doesn't mean anything. The first one has some, like the third point there is technical, so you have that, right? You have something there. Okay, let's look at the projects. Workout tracker, JavaScript, Node, Express, MongoDB, React. Okay. Full stack applicant track detailed workout for using MERN stack. Create API endpoints for CRUD operation. Blah 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 blah. Okay. Yep. Integration. Okay. Do something control based on things. Okay. Good start. This is a good start for a solid full stack application, right? Two things in this one for resume's sake. The first thing for resume is you gotta have a date here. Date, ideally have a link as well, right? The second thing is how do you improve this? Well, you have a full stack app. You can improve it by deploying it, right? You can deploy it, and then if you deploy it, then you have a link down to the source code. You have a link to the actual, to the actual page, to the web app, right? So I think that's kind of the next thing you can do here to kind of improve this project more. All right, event management, blah 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 blah. Okay, this is like whatever. This is fine. I'd say yeah, okay. I'd say once you expand workout tracker, that should take up more and more room. You can cut this down to like 1 point. This is not gonna be relevant anymore. Student record keeping, database management, design implementation database. Okay. Okay. Okay, so a couple things here. So, there's a couple things about this one. The first thing is, if you want to talk about databases, and you're talking about efficiency, right? Efficiency, scalability, optimization, and then you also use 1,000 records as proof. You know what I mean? Like, this is just obviously a school project. So what I would say instead is talk about some of the more academic things that happen. So for example, you talk about a normalized relational database schema. Okay, that's a good start, right? What normalization? Is it second normal form, third normal form? Is it BCNF? Like, what normal form are we talking about, right? Be a bit more technical on that one. That could be good, right? You're talking about, for example, also to reduce redundancy. Okay, compared to what normalization form? Compared to a denormalized database, compared to like a 1NF, 2NF, right? By how much, right? Improve query efficiency by how much? So there's a lot of things that you can quantify on this one that you should, because the only quantification you have right now is saying 1,000 records. Dude, 1,000 records is not worth spinning up a database for. This is fine. Lowercase p though. All right. So for this one, they said I am a recent grad applying for Python focused backend positions. Python focused backend positions. That's surprisingly limiting. I wonder why that's the case. Oh, I see. Okay. This is also the last resume in the queue, by the way. So if no one submits a resume after this, we're calling it here. Honors Bachelor of Science, University of Ottawa, major computer science, minor mathematics, GPA. Okay, that's fine. What I will also say, by the way, is don't use the vertical bars because that's not very parsed very accurately most of the time. Okay, developed a Python T resolution package I could learn, lowercase s. Modular API extend. Okay, what? This is intro. Okay. Check workflows, 30% actually, 30% 5%. Okay. Okay. Streamline highlight with SQL queries in Oracle PLSQL. Okay. ETL pipelines automate transaction analysis, report generation, Python pandas. Lowercase b. Improving entity detection by 50%. What is this? Entity detection by 50%, enabling real-time reporting to support fraud prevention initiatives. Okay, I see. Okay. This feels similar to this point, but one's about SQL, one's about ETL. Okay. Lit backend optimization, clean code practices. Okay. So this is obviously the bulk of your experience, right? This is a year. This is like half a year, nothing else, right? And this is DevOps. So what I would say is, like, again, utilize the nested header pattern, right? Your title, company, like you have right now, presumably, right? First thing should be what? First thing should be fraud detection analysis performance, right? Fraud detection. Fraud. You have 2 points here already, right? And by the way, the reason I say this is because you're going for backend, you gotta have performance numbers. So this is good to spend the time and spend the space to talk about that, right? If you got more points, put them in, right? And then what else you got? And then you got scikit stuff, ETL stuff. I would say like like Python. That's a bad. I mean that's a bad header. I don't really know what this is, right? Entity matching. So they call it entity matching workflows, right? Put your put your first point there. If you have other stuff there, put it there as well. The last one I feel like is a bit of a show don't tell. So for example, if you want to talk about your 4 high impact projects, you can for example adopt another one, which is like you just put project 1, right? P1, P2, P3, right? P4, and then under each one of these have like 1 or 2 points. Why is it? What did you do? Why is it impactful? You could do that as well. So there's a couple ways to organize these points. I would say pick one and go with it because this is a year long. This is much longer than everything else you have. So this is gonna hold the most weight on the resume. Okay, DevOps, configure monitor fitness Azure. Okay. Yeah, this is fine. 3 points is just what it is. It is what it is. Nothing there really about backend. Okay, Python. This is Python. Wait, what? What is this? Let an open source initiative building a scalable ETL pipeline aggregate 1 million parliamentary expenditures, transferring raw government data into Kubernetes data center. Okay. Launch the Next.js Tailwind web app with Python RESTful API. So, okay. Featuring rate limiting, caching data retrieval, super-based database schemas, optimized SQL queries enable. Okay. The obvious question here is what Python API is this? Flask? Do you have Flask? You don't have Flask. Okay. Lowercase s. What would I say? I mean this sounds fine. This sounds fine. It's a bit devoid of details though. Right, like what APIs are we supporting? For example, are we supporting a generic get data API? Are we supporting arbitrary SQL string APIs to run SQL on the server? Like, right, like there's such a large variety of APIs that could fit the bill here because it's so general. So I think that lack of specificity is hurting this one. Okay, Next.js Tailwinds. Okay, TensorFlow, scikit-learn. What the hell is this? Engineer REST API, Fast API, OS. Okay. Okay, so there's a lot of technology here. What does it do? Okay, so it's about markets. Okay. I feel like this point is conflating two things, though, right? Like you're conflating training a model and then asking the model to make an inference. Start training sim. Okay. Start training sim. Yeah, I feel like the second point is still conflating training models and inference from models. Because this part is training, that makes sense, and then this part is inference. But that's fine. That's fine. These two feel quite similar. At least the tech stack does. That's fine. Supabase. I don't know what schema they have, but it's a self. Wait. Where's this Python hosted? Okay. Build DNS servers from scratch. That's pretty cool. If you're going for networking jobs, this is quite good. If you're not going for networking, I don't think this really makes a difference, frankly. But that's fine. I would also say, like, your experience is decreasing chronology, this should be the same. Right now it's the other way around. So I think you should flip this. Python, OpenCV, Grok, MQTT mentioned. Okay, real-time foundation system, blah blah blah. Just okay. Okay, that's fine. All right. Okay, the main thing here is there's a lot. There is some diversity in projects, but you're going for Python backend. Python backend, I don't see many Python backend technologies here, right? Like there's a Python backend for machine learning, data science stuff, right? That makes sense. That's great, but you didn't say you're going for that, right? I would say the kind of number one thing to cover your bases for a Python backend is a Python backend framework, like for example Flask. In fact, I mean, obviously, I don't know Python very well. I mean, I know Python. I don't know the Python web dev scene very well. The only thing I know is Flask. There's something else there that's also good. You can use that as well, right? I'm just giving an example. It doesn't need to be Python backend. I just said that because it's the majority of my experience. Yeah, well, I mean, I've seen that in general. Like in general, there's no backend technology, right? I know there's Flask. Do you have Node? You don't have. You have no. That's not Node. You don't have Node. There's no Spring. Right. So there isn't a backend framework here. So you have a lot of backend technologies like SQL, for example. I saw fast. You have API stuff going on there. That's good. That's backend. But I think there's kind of a hole right now. No, it's just a gap in experience. So I'd say you like Python, no problem. Make something in Flask. Right, make something in Flask, because if you're going for Python roles, that's going to be one of the requirements is to have something like Flask. But the thing is, like, if you like Python, that's great. You can learn Flask very quickly, and then if you find that a lot of the jobs you like are, for example, all in Java or Scala or Kotlin, JVM languages, and they're asking for Spring Boot. Well, if you know Flask, then it's much easier to move on to Spring Boot, right? So by learning Flask, you can leverage your knowledge in Python to at least get a head start on that knowledge. Okay, let me check. Anything else? Nope, that is all. Can you explain the way to format a 1 year experience again? Very simple. Because your experience is 1 year long, your other experience is 6 months long, and it's not. It's DevOps. It's not that relevant. You need to put a lot more weight and therefore give space and time to talk about your relevant experience. So what I would do is there's two ways to do this, and you can decide for yourself which one you want to do. The first way to do is to have approximately 2, maybe 3 headings like such. You have one about fraud, and you talk about your this point over here, this one over here. You can add more points about that if you need, right? And you have some stuff about your ETL pipelines. Right, so for example, this is also overlapping ETL. For this one, focus on how that ETL pipeline helped your fraud detection thing. Right, for this one, focus on the technical aspect of the ETL pipeline. And I also know, for example, your first point here is also about entities. I don't know if this is the same. This is not ETL necessarily. I can't really tell, but this sounds to be also like related to that. So put those two together. And then these two, of course, you can group these as something else, right? So, for example, was a good team player, whatever we want to talk about. The second thing I saw, which is what you said in your last point over here, is that you had 4 high impact projects. So I said, okay, you could also do this might be cleaner for you to organize this way, right? And I say that because I don't know what you did here, so I can't really help you with the themes, right? But this is very concrete, the 4 projects. So I have 4 headings, one for each project, and for each project you can have 2 points. The first point is why is it technically impressive, and the second one is why is it important, why is it high impact, and you can organize it that way as well. So many different ways to organize it. The reason I say to do it this way is because it takes up more room, because you need more room to talk about it, right? Talking about this is a lot more important than emphasizing what's going on with your CNAME records, right? This is really not relevant for backend roles, unless it's specifically like a networking role. If it's networking, then it's very relevant. If it's not networking, it's not relevant at all. So, just in terms of space allocation, that could be improved, and that's how I propose doing it. Okay, we're actually right on time, so we will call it here. Thank you, everyone, for tuning in.